Let's start with Laurent Bugnion.
Yep.
Sorry.
No problem.
Working for Valorem, he's a senior technical evangelist, and he's going to introduce Xamarin to who doesn't know what it is. So please welcome him. Laurent, thank you very much for being here.
Thank you, Eugenio. All right, welcome everyone. Thank you to the organizers for inviting me. I'm very happy to be here, especially because I often speak to Microsoft communities. I do quite a lot of talks about Microsoft technologies in general, but it's always good to kind of build bridges between communities and show you a little bit how things work on our end, I would say. I don't know how many of you do work with Microsoft technologies in general. And so I'm going to talk about the Xamarin programming platform. This is a 101 talk, if you want. So even if you have never heard of Xamarin before, well, you will have in 40 minutes. And if you have already, then it's a good recap, I hope. So about myself, I work, like Junior said, for Valorem. We are Microsoft partners. We work a lot with Microsoft technologies in general, including all the platforms, really. So from Windows to Windows Mobile, yes, there is still that, Xbox, HoloLens, etc. I'm a Windows Platform Development MVP and Xamarin MVP, so those are most valuable professional programs, so basically some partner programs, some awards that Microsoft gives. And I'm also one of the 2 regional directors for Switzerland. I'm not paid by Microsoft in any way, but as you can tell, I make most of my living with Microsoft technologies. All right, so moving on, I like to do a recap of the history of Xamarin because I think it's important to know where we come from so that we know where we are going, right? And so Xamarin was founded in 2011, which sounds fairly recent. I mean, okay, in the meantime, they have 6 years, profitability. They have had a big growth as well, going from just a few employees to more than 1,000 people now. But in fact, their history is a lot older than that. And the history really starts with the birth of .NET. When .NET was created in 2001, .NET was actually published as a specification by Microsoft. And so basically, it means that everybody was free to take the specification and implement it if they wanted. And so Microsoft did the Windows implementation. But then there was this crazy guy called Miguel de Icaza. I don't know if you heard of him. He's a kind of free thinker, and he was quite a personality in the open source world, still is, because he was the guy who built the first GNOME desktop for Linux. And he decided at some point to assemble a team and to build a specification and to build .NET for Linux according to the Microsoft specifications. And that was called Mono. Mono in Spanish means monkey. Miguel is Mexican in origin. And so that explains why if you go to Xamarin.com, you'll see a lot of monkeys everywhere. And they have some very cute monkeys that they give away at conferences. It's really nice. So they built Mono. They built something called MonoTouch for iOS when iPhone came out. And then they built Mono for Android. And so you had already the possibility very early to program for those platforms using C# and .NET, an implementation of .NET for those systems. So this group of people worked under the name Ximian, and then Ximian was acquired by Novell in 2003. Novell continued to maintain the open source project Mono for quite a few years, until unfortunately, or maybe fortunately for us, Novell was acquired by Attachmate. And Attachmate is a huge firm. They have very strict business objective, and they say, well, that Mono project, we don't want it, and so they laid the team off, which, oh my God, right? And in fact, it was actually good for them because they were allowed to take the source code and the licenses, and they decided to found Xamarin in 2011. So they changed the business model because sometimes you have to eat, and so they decided to publish that under a subscription model, which was fairly expensive. So a lot of people saw that a little bit as a blocker. But on the other hand, a lot of big firms started to adopt Xamarin as a solution to develop applications for iPhone, iPad, Android tablets, etc. And then move forward, in 2016, Xamarin was acquired by Microsoft. Now this is a bit of a history in itself. I do believe, personally, without having proof of that, but I do believe that Xamarin had been approached by Microsoft already before, because most probably they had been. It totally made sense. And I do believe that they said no. I think so. But Xamarin and, Microsoft changed a lot in the past few years. And I don't know if you have followed that. Microsoft kind of had a bad rep, especially in the open source world. They have opened up so much in the past few years, that's amazing. Microsoft is actually the first, in terms of number of contributions to GitHub, they are the first enterprise, right? .NET is open source, a lot of their tools is open source, a lot of their frameworks are open source nowadays. And the firm has changed so much that Xamarin, who was really the paragon of open source thinking and of, you would say, of free thinkers, decided to accept the acquisition offer and to join. And so that's been working pretty well for them. It was almost exactly a year ago. And so since then, they have been integrated into the Visual Studio Tools division. And they continue to work on their tools. The tools become more and more stable through that because now they are part of the family, which is a really good thing. So currently we work with Xamarin version 4.2, which is pretty stable. It's quite a good solution. And so let's talk about the principles, how it works. So the idea is that you code in C# or F# if you want to. Basically, it's a .NET language, okay? C# for Java people is super easy. You just change the capitalization of the method names. Then you're good to go. It's almost that. It's a little bit more complex than that, but I came from Java and I moved to C# back then, so I remember that the switch was not really that hard. It's pretty much Microsoft had something to C#, Java adds it, or Java adds something and then Microsoft adds it, and basically for people who do Objective-C and Swift, it's a little bit more of a learning curve, but C# is a very friendly language, so it's nice. Now, the cool thing with that is that you can also take advantage of the .NET framework. The .NET framework is huge. You have a lot of classes that you can use. For example, later I'll show you HTTP client, which is a real great, convenient way to do HTTP calls, REST calls, etc. The whole asynchronous libraries, etc., etc. And not just the .NET library itself, but also all the tools around it. So, of course, you have Visual Studio, which is a tremendous tool. But also a lot of tools in the ecosystem. For example, Windows developers typically use something called ReSharper. It's a third-party product, and it's really great for productivity enhancement. It's very, very nice. The .NET framework, of course, but also libraries and components, because there is a huge open source community around .NET. And we have package managers that we call NuGet, which allows you to very, very easily add components to your applications. And most of those components are built using something that we call a portable class library technology, which means that those tools are actually portable and will run on iOS and will run on Android as well. Okay. Now you can also add native iOS components or Android components to your applications. And here I'm talking about the UI, for example, because the UI is fully native. We are using an actual UI button, actual UI labels, or on Android, actual Android buttons, or Android text view, etc. So the UI is totally indistinguishable from an application built with Objective-C, Swift, or respectively Android. It's exactly the same controls that we use. It's not a hybrid application where we fake that we are an iOS app or an Android app. We are actually an iOS app or an Android app. But you can also use those components not for UI, but for something else. Like, for example, if you have a library that you like, well, most probably it has been wrapped already and you can use it in your Xamarin applications. Or maybe you have to wrap it yourself. The wrapping is just a kind of marshalling between the .NET world and the unmanaged world. It's fairly easy to do. We did that already a few times for some of the components that we use. You also have access to native iOS and Android code, should that be necessary. Most of the time it's not, but sometimes it's good to have really access to the metal, okay? And you build native executables. And so those applications are fully native, okay? Now in terms of tools, we use primarily two tools. If you're on Visual Studio on Windows, we use Xamarin for Visual Studio, which is an extension to Visual Studio, so it's integrated into the Visual Studio development environment. We have a designer for iOS and for Android. Now, if you don't want to use the designers which are in Visual Studio, it's okay. You can do your design in Xcode and then import it, because we use actually storyboards for the UI, okay, in iOS. Android, same thing. If you want to do your UI in Eclipse or whatever tool you prefer, you can do that and then just import it. That works. which is really nice because it allows us to work with people who are iOS designers, for example. And those people don't even know that the UI they built is going to run on Xamarin. It's irrelevant because anyway, it's going to work, okay? On the Mac, there is a Visual Studio for Mac, which I wrote preview, but it's actually built on a product which was released by Xamarin called Xamarin Studio. Xamarin Studio is slowly being deprecated and replaced by Visual Studio for Mac. This allows you directly on the Mac to build using C# and .NET, iOS, Android, Mac OS, but also some .NET applications, for example, ASP.NET if you want. So the cool thing with Xamarin is that you don't program just for iOS, for iPhone and iPad, Android tablet, Android phone, but you have access to the whole ecosystem. For example, you can build for wearables, okay? Android wearables. You can build for Fire TV because it's just Android. So anything which is Android basically is going to work. You have access to the Apple Watch, Apple TV, etc., etc. They have SDKs for the functions that are specific to those devices, but for the most part, it's just like programming for an iPhone or for an Android device, okay? All right, now setting up. How do you actually set up your environment? So we have options, which is always good. And for example, for myself, I like my PC because once you go touch, you never go back. So I like my touch screen. So I have a Surface, and this is my main device. I have Visual Studio on it, and then I can build Android applications directly from there. And then if I want to build iOS application, well, Macintosh, Apple makes basically money from devices. So they force you to have a Mac somewhere on the network. It's a pure license technique thing. And so many people use a Mac Mini, for example. Many people like me, I have an old MacBook that was laying around somewhere. Nobody wanted it. I took it. And that's my build server if you want. It just has to be somewhere on the network. Now, the thing which is nice is that you can also use something called Mac in the cloud. You might be familiar with that because the license, I don't know. I'm not a lawyer, so don't sue me if that's not correct. But I was told by lawyers that Apple just requires you to have a physical device to do the build. And since Mac in the cloud is actually a physical device, which just happens to be somewhere in the cloud, that should be okay. So it's also possible to do that. Now, of course, in terms of latency, etc., I'm not sure I really want to do that. So basically, I have a Mac on my network. That's what I use. An alternative to that is using Visual Studio for Mac to build your applications. And so you can build directly Android and iOS applications. The downside of that is that, well, it's not the full Visual Studio. So if you have a team which is used to Visual Studio to the full thing, then they are going to miss a few things here, okay? And really, the full-blown Visual Studio is very powerful. So if you miss some of the features, that can be an issue. And so there is an alternative which a lot of people actually use. They have a Mac, and then they put a virtualization system on it, and they put Windows on the Mac. And like this, you can switch from one to the other. That's also a possibility. Disadvantage of this solution, the advantage is obvious. You have just one device. Disadvantage is that you don't have a touch screen. Sorry. I like to mention that. Anyway, no, the biggest disadvantage is just the virtualization of Windows. It can be a little bit tricky sometimes, but from what I hear from my friends who do that, it works fairly well. So as you see, we have a lot of options to build this type of applications. Debugging emulator, well, basically you can use the emulators of the Android SDK on the Android side. That works. Genymotion is a popular solution. Of course, it is subscription-based if you do any type of commercial application, so you need to take that in account. A lot of people don't know that on Windows there are some Visual Studio emulators for Android, and they are pretty good. In fact, they are very good. They have a lot of features. For example, you can simulate the geolocation. You can build a route and have simulations that you are walking that route or driving that route, etc. You can simulate SD cards, simulate connection status, like for example, what happens if my network goes from Wi-Fi to 4G or to 3G or to 2G. You can simulate battery status, etc., etc. So it's a very powerful emulator. On the iOS side, we use the iOS emulator. Now, there is a possibility in Xamarin to actually import that to your Windows PC, should you be using a Windows PC, which is really cool because then suddenly you can use touch on the iOS emulator, which you cannot do on a Mac. And not just touch, but they actually built multi-touch inside. So you can also pinch to zoom, etc. And you can also use, where is my pen? Here. On Surface, we have pens, for example, on many devices, and you can use that to simulate the force thing. So basically, you can really test your application in real conditions. All right, so let me show you a demo. So I'm going to switch to Visual Studio, all right? And so I prepared a small application. And so basically what I did, I went to File, New Project. And because I have Xamarin installed, I have Android here, I have iOS here. And so I selected here an Android blank application to start with. And if you open the designer, this is how it looks like. You have access to the source code, of course. Here we go. The designer is a little bit crude on the Android side, but like I said, you can always use another environment if you want. So I'm going to take a button, and I'm going to take a text view. Here we go. Now let's go and change the properties of the button a bit. So what I will do, I will just change here the ID to my button because I'm very creative. And I'm just going to change the text to say, click me, all right? Then this text view here, I'm going to change the text to nothing yet. I'm going to, what am I going to do? I'm going to change the ID to call it my text. Here we go, oh gee, my text, okay. And let's change the gravity. And so here you see what I'm doing, I'm actually using the Android APIs, right? I mean, center, horizontal, gravity, this is something which is Android. So the good thing if you come from Android and iOS is that the UI, you know it already. You don't have to learn that. The only learning curve you'll have is basically going to C# and learning the .NET libraries. But in terms of UI, it's really the same. Now, if you come from Windows, that's exactly the contrary. You know .NET already, and then you have to learn how UI is working on Android, and especially on iOS, where the UI stuff is a little bit of a mess, if I may say so. But basically, you learn it, and then after that, you're good to go, right? Let's change the text size. I'm going to set that to 32 dp. OK. Now I'm going to code against that. So I'm going to go to my activity. And here, this is where we are at the boundaries between .NET and Java, if you want. So it's really an interesting place, because what I'm going to do is go and get the button. So I'm using a method called findViewById, okay? And then when I have my button, I'm going to implement the click event handler. Now the cool thing is that this is an Android click event handler, but I'm handling it the .NET way using an anonymous lambda expression, okay? So I'm exactly at the boundaries where I'm coding against the Android API with the .NET paradigm, okay? I find that fascinating. I don't know, maybe it's just me. I have weird hobbies. I find that absolutely fascinating, personally. But anyway, moving on. And then I can implement that. So for example, I'm going to take the text view. I'm going to, I don't know, count something here. Let's add this field, all right? And so if I was to build that, and you see I have my Marshmallow Android running. So this is the the Android emulator running. I already built the application because I didn't want to lose time. So here we go, and then I click, and it works. Ooh. And now I make money with that. No, probably not. So anyway, let's do something a little bit more fancy. I'm going to go and take here an HTTP client, because I want to connect to the web. So HTTP client is how we do web calls in .NET, typically, especially good for REST. It's very, very friendly. But of course, there is no HTTP client on Android. What do I do? Well, the good thing is that we have this package manager called NuGet. And so I'm going to go here and call manage NuGet packages. I'm going to search for HTTP client. And there is this system.net.http, which in that case is prepared by Microsoft, but it could be a third-party product exactly the same. I'm going to add it to my solution. So it's just downloaded everything you need. And once this is done, I can start coding using this API. So it's very, very convenient. All right, so now I have access to HTTP client. So now I can do a call, for example, get string async. This is an awaitable call. This is how we do asynchronous calls in .NET. Super convenient because you don't have to worry about callbacks anymore. You just put await, and then basically in the background, .NET is going to create a callback for you. This is not a blocking call, right? It's just an asynchronous call. But then I can continue inline, and the callback will just come back here when the asynchronous call is done. So it's really a nice way to program. By the way, my friend Damien here is going to have a talk later this afternoon where he will go a little bit deeper in detail about that, or quite a lot deeper, I expect, knowing Damien. So feel free to check his talk if you want more information. Now I just need to add the asynchronous keyword here to signify that it's an asynchronous method. And then what am I going to do here? Well, basically I'm going to go to this YouTube page, and this YouTube page is where I have my drone videos. So I'm an avid drone filmmaker, and of course I'm also very vain, right? I love to see how many views I have. And this number keeps changing all the time. You have no idea. In 1 week I can get 2 more views at least. So, so I love every morning when I wake up, I need to check how many views do I have, right? And of course I want to do that on all my devices, iOS, Android, and Windows. So of course it makes sense to make that in Xamarin. So I have this very boring code which is going to parse the HTML, and this is code that you want to have only once in your applications, right? You want to write it once, unit test it, and then never touch it again because this is super bad code, right? It's, oh my God, parsing HTML. So great for Xamarin, as I said. This is a code that I'm going to share between my applications. So if I was to run this application here on Android, here we go. Normally it should work. I had some issues with the internet before on the emulator, but here we go. We have 167 views. Very good. Now, how do I do that in iOS? And why not Windows, since we are at it? So what I'm going to have here is a full-blown application which I built using Xamarin. And here what I did, I have created a portable class library, which is a library that I'm going to be able to share between iOS, Windows, and Android. And I moved the horrible parsing code there. You see, it's here. So basically, I built a service with a refresh method, and then I'm going to call this service. Now, that is the shared code. That's a portion of code that you write once and unit test and then never touch again, okay? Until the specifications change, which they tend to do 2 weeks before release or 2 days before release. Okay, and then I have my Android application. It's pretty much the same application than you saw, except that now I'm instantiating the service and calling it. And I have an iOS application. I'm not going too deep into the details here. You'll get the code. It's all on GitHub anyway. I have the service, and then I'm calling it. And you see I'm using a UI button, and I'm using a UI label here. And then I even have a Windows version where I am, surprise, surprise, instantiating the service and using it. Okay? And so now I have an iOS version of the application. I didn't take my Mac because, well, I like to travel light. But I can show you a quick video, and here we go. And basically, no surprise, it's going to just work. It looks and feels like an iOS application because it is, in fact, an iOS application. Here we go. I click, and then it refreshes the number of views. Okay, that was, I don't know, probably 6 months ago, I guess. And I also have a Windows version of the application. And so this is a Windows Universal application. So it runs on my phone, it runs on my desktop, laptop. It would run on an Xbox as well. It also runs on HoloLens, which is pretty cool. So I can click and see the number of views. Perfect. All right, so this one here is what we call the Xamarin Classic, the Xamarin iOS, Xamarin Android way of building stuff. This is where you have full control on your UI. You own every pixel. And then you can go crazy and build amazing applications. And then you share the business logic, okay? Which can amount to 60, 70%, no problem. Maybe with a clever architecture, you can even go further. I mean, we have some applications where we share maybe up to 80% of the code. But then you do the UI specifically for each platform, which is great because you can work with iOS designers, professional people who do that all day long, and basically no compromise. Now I'm going to show you something else, which you might have heard of, which is called Xamarin Forms. So Xamarin Forms is an addition on top of Xamarin. And what it allows you to do is share not just the business logic like we just did, but it also allows you to share the UI. So you're going to define the UI once, and then it is going to be rendered to the different platforms. Now, of course, the rendering process forces you to make a few compromises. Okay? If you define the UI once only, for example, let's say that you put a button in the center. Well, on iOS, buttons tend to be rather in the navigation bar, for example, etc., etc. So here we are talking about a compromise application where you say, well, the UI is good enough for what I need to do, as opposed to the Xamarin Classic version where the UI is pixel perfect. You see where I'm going, right? So you define the UI once, it is rendered. Now that's cool for business applications, for example, applications which are not necessarily consumer-facing. Consumers tend to be really picky about UI, right? They want to have the look and feel of their iOS application. But for a professional who is paid to use the application, suddenly it's a lot less relevant, these kind of things, right? So business applications, and in fact, that's where the name Forms come from, right? Xamarin Forms, because it was built initially in the idea of doing business apps, Forms application, like stuff where you have to fill things. But it's also good, for example, if you do some prototyping work, like let's say that you have a very complex service that you want to test on all the platforms, you build a quick UI prototype, you build the UI once, and then you can test on iOS, on multiple devices, test on Android. You can show to your boss, to your stakeholders, prove them that the service is working, okay? Another thing which is good is that you can actually evolve your application, so you can start in Forms and then gradually replace some of the pages with a view controller in iOS, with an activity in Android, and evolve your application like that. So it's also a possibility. We tend to see more applications developed with Forms. There is a place where you have to be a little bit careful. I call that the pain threshold. This is when it becomes painful to have to adapt the UI for every platform in Forms because you want your application to look and feel like an iOS application. So before you start the project, make sure to evaluate that, okay? If you can go with a good enough UI, it's a great solution. If you want to go with a perfect UI, then maybe it's not the best solution because it's going to be a big effort, all right? We're engineers, we make compromises. That's what we do, right? All right, so you have pages, panels, and layouts. Now, the cool thing is that Xamarin Forms is actually adaptive layout. And they are just going to, on iOS, you know, the adaptive layout way on iOS using constraints is quite different from the Android way or from the Windows way. And so here, Xamarin is going to take care of that for you. So they have a stack layout, they have an absolute layout, they have a relative layout, they have a grid layout, which is pretty cool. Notice the master details page, which is really great when you want to quickly build something with a drawer, and then on the tablet, it's going to render as side by side, so it's pretty cool. They have controls. Now, if you don't have enough controls, you can actually get controls from providers. There is a nice ecosystem around Xamarin Forms, for example, gauges or charts or stuff like that. And since you build the UI once and run it everywhere, like I said, you make some compromises, right? But you have possibilities to adapt the UI on every platform. Like, for example, one way is to say, directly in your UI markup, you're going to say, on the platform iOS, this property value should be so-and-so, but on the platform Android, it should be so-and-so. Great for margins, because margins tend to be very, very different on iOS and on Android, right? But also, I don't know, you can even change the color or change basically any property. So that's one way to adapt your UI. Another way, the way that Xamarin Forms work is that then if you define a Xamarin Forms button, it goes through what we call a renderer, and then this renderer is going to say, oh, I'm on iOS, I'm going to use a UI button. And that is a default renderer. But you can also customize those. You can build your own renderers. Now, that's quite a lot of work, but you can really say, in case of a button, on Android, I want to use a view with an image instead of an actual button. So you can really rewrite the whole thing, should that be necessary. Now, one thing which is pretty cool, they just added that recently, you can embed native controls in your markup. So you can have a markup, we use something called XAML, I'll show you a quick example in a moment. You can actually say, okay, I'm going to build the UI once for iOS, Windows, and Android, but on Android, I want to take advantage of the floating button, which is pretty cool. And so you just add it to your markup. Then it's going to be ignored on iOS and Windows, because they don't have that control, but it's going to be used on Android. And you can do that for every platform. Another thing which is good to know is that we use something called XAML in Xamarin Forms. XAML was created by Microsoft in 2006 already in something called WPF. Now we use it pretty much in a standard manner to program for Windows everywhere. It's a very, very powerful markup language. It's adaptive. It looks very much like the Android XML, so it's not totally unfamiliar to those of you who come from Android. And then it also allows you to do what we call data binding, which is really nice because I don't know if you heard of data binding, but basically it was created by Microsoft in something called WPF long time ago. And now it has really spread a little bit everywhere. For example, if you do Angular in HTML, right, you use data binding to bind your model objects to your HTML using JavaScript interface. Well, that all originated on the Microsoft side about 10 years ago, or a little bit more than that. And in Xamarin Forms, you can also use data binding, which provides a nice separation between your model code and your UI code. All right, let me show you a quick run through the code. So I have here a Xamarin Forms application. And so the way that it is structured is that, you remember this portable class library where I did my model? Well, here I have a portable class library, but this time it is my UI library. So I define the UI once, and then it's going to be used by my Droid application, my iOS application, and I even have a Windows application here. So how does the UI look like? Well, here we go. This is XAML, okay? As you see, it looks very much like XML. In fact, it is, of course, XML. I have a stack layout, which contains a button and a label. And then I said, on the platform Android, I want the label to say hello Android. On iOS, I want hello iOS. So basically, I customize my values for each different platform. And here, I even added an Android widget, which comes from this mono.android assembly up here, okay? So I have an Android widget, which in that case is super simple. It's a text view. It's just to demonstrate the principle, but I could use any Android UI. And if I had an iOS UI element, well, same thing. I can add it, and it's going to be used only on iOS, not on the other platforms. Okay, in that case, I didn't touch those three applications. So I did all my code here. And now if I run that on Android, this is how it's going to look like. By the way, you notice that they use material design by default. You can, of course, change that. It works, and here I have my native text, which is a native text view, which is going to be rendered only on here on Android. Now, if I go on iOS, same thing, I did a quick video. I'm going to click, and you might see, I start having some issues here. For example, the margin on top should be bigger. So it means I'm going to have to start customizing my UI for iOS, or in some cases for Android. So this is where I said sometimes you have to check how much work is it going to be to customize the UI. Okay, but basically out of the box for a prototype, for example, it's, again, keyword good enough, right? Is it good enough? Well, up to you to decide. Personally, I'm a stickler with UI. I like my UI to be pixel perfect. All right, and then I have the UWP, the Windows version, and this button on top is not typically how we do things on Windows. We like to have a command bar, etc. So probably I would, again, start customizing my UI for Windows. Okay, but it does work. All right, so that's kind of an overview of those two platforms. Now I want to take a quick moment to show you what else you can use in Xamarin. And one thing which I wanted to mention, because it can be useful to those of you who do applications, even using, on iOS Objective-C and or Swift, on Android using Java, you can actually test your applications on physical devices using a service that Xamarin provides. Now, this part here is not free anymore. Everything I showed you before, this is free of charge. You can use that, no problem, right? Here, you have to pay a subscription, and basically you pay by the minute, by the number of devices that you want to test. They have literally thousands of real devices in containers, and then you can upload your application to those devices, and then you can script UI tests. The scripting happens using C# or JavaScript or whatever scripting language. They have a few, okay? And then you can say, well, on that particular application, I want to click on that button and then take me a screenshot, and then click on that button and then wait 2 seconds and then take another screenshot, etc., etc. And then you can really write your tests. Cool thing with that is that those are physical devices, so you even have access to physical buttons like the camera button on Android devices or maybe the home button, etc. You also have access to crash information, should that happen. Well, I know we don't write bugs, but you never know, right? So if the application crashes, you get the crash information, call stack, and everything. You have a nice visualization where you see all the devices that you subscribe to, and then you can see, oh, that one failed. Why is it so? And so you literally have thousands of operating system / platform version / device model. So you don't have to maintain that yourself, because that's a real effort, right? First of all, you have to buy the devices, then you have to maintain the updates, and you have to make sure that you have also all the versions of the UI of the operating system. So here you have this possibility to delegate that to Xamarin. Now, the other thing I want to mention is the Xamarin University. So should you be intrigued and want to go further, you have the possibility to subscribe to the university. It's online. The nice difference with a lot of other services is that those are live classes with a live instructor. And those guys are human, I checked. So they answer questions, which is pretty good. And honestly, the Q&A part, the discussion part, is very often the best part of the session, okay? I had sessions where literally we ran over by 1 hour because we were starting to talk about architecture, things, or whatever. So really nice way. You have exercises and samples. You can get certified. This is a certification which is valid for 1 year, and then you have to renew it. The renewal is used to be quite complex. Now it's a little bit easier, but basically it's a nice way. Used to be fairly expensive. Now they have a model where you can pay month by month. So if you want to just try it out, for example, take a few classes, you subscribe for 1 month, and then it becomes suddenly very reasonable. They also have a model for students, of course, so this is cool. They also have guest lectures. I spoke there, I think, last year. It's all online, so you can, sometimes listen to lectures on a topic which is not necessarily a standard Xamarin topic, which can be really cool. All right, so I'm pretty much at the end of my presentation. So in recapitulation, if you want to share code, like business logic code, but have a full-blown, full native, no compromises UI experience, the Xamarin Classic way is the way to go. Xamarin iOS, Xamarin Android can share easily 60%, 70% of code, maybe even more if you do a little bit of architecture and pay attention to a few things. If you want to share your UI as well, in addition to the business code, you can use Xamarin Forms, some compromises in the UI, okay? But you do have, it's still not a hybrid solution. It is still using full native controls. It is still providing the iOS experience. And this is great for line of business, prototyping, iterative development, etc. Few links. You'll get, of course, all the slides and source code. I will publish everything to my website, so pay attention to my Twitter, Bugnion, and the next couple of days, or maybe even today, if I have time in the train, I'll push that to my application, and all the samples are on GitHub. So I hope it was helpful for you. I hope you have a better idea of what Xamarin can offer. It's a cool development environment. And honestly, Microsoft, they change a lot, so come back. I hope to see you maybe at another conference at some point. I'm going to stick around a bit more, so if you have questions, don't hesitate to come, and have a lot of fun at the rest of the conference. Thank you very much.